Okay, today's lesson for SL Prep is Chapter 4.3, Systems of Linear Inequalities. This will not be done in studies, so it's something that if you want to know it, you're going to have to get it from this video. So y is less than 2x minus 3, and y is greater than or equal to negative x minus 1. It's in slope-intercept form, so we're going to graph it using m and b and a slope triangle. On the first one, the m is 2 and the b is negative 3, so we plot negative 3, this is my red line. We go up 2 over 1, up 2 over 1, up 2 over 1, and so on. This is a broken line because the inequality does not have an equal sign. In the second equation, y is greater than or equal to negative x minus 1. The y-intercept is negative 1, the b is negative 1, and the m is negative 1. So it's going to fall from left to right. Plot a point at 0, negative 1. Go down 1, 1 to the right. Continue on. I'm going to go back up 1, 1 to the left as well. Connect your points with a solid line. It's solid because the inequality symbol has an equal sign. Down. Go ahead and write this down. Your goal is find all the solutions for these two inequalities. And as you know from the earlier lesson on inequalities, inequalities don't just have a single solution or solutions that are just on the line. They're going to be a lot of ordered pairs. So we're going to go ahead and look at each line. What we have to look for now is a point that we can choose that will work for both lines. And if we look at, we can see that 0, 0, neither line goes through 0, 0. All right, graphing the lines is relatively simple. It's relatively straightforward, and you should know how to do that. What is going to be more challenging is figuring out where to shade, because the shaded area shows all the possible ordered pair solutions. So we're going to use 0, 0 since neither line goes through 0, 0. So we substitute in 0 in the first equation for y, 0 in the first equation for x. So we have 0 is less than 2 times 0 minus 3. 0 is less than 0 minus 3. 0 is less than negative 3. That is false. And if it is false, you do not include 0, 0 in the shading. So if we're not going to include it, then we come over here. Here's your line. This is the y is less than 2x minus 3 line. And you are going to shade to the right of it and not include 0, 0. But we don't want to shade yet. We're going to just make little x's all the way down the right side of the line. Okay, now you need to determine what the solutions will be for the blue line. That is your y is greater than or equal to negative x minus 1 line. And you're going to use 0, 0 because it does not pass through. The line does not pass through 0, 0. So we're going to check 0, 0 in there. So we put in 0 for y into the second equation. We've got negative x, so we're going to make it negative 1 times x. Negative 1 times x is 0, minus 1. And then you've got 0 is greater than or equal to 0 minus 1. 0 is greater than or equal to negative 1. That is a true statement, so we're going to shade, and that's going to be shading above or to the right, and include 0, 0. And now what we're going to look for is where it is going to be sharing x's. So the x's come along the right side of the red line and then on the left side of the blue line. This is where they are meeting. So your shared area is the shaded area to the right. Now we're going to pick a point in that and we're going to actually check it out and see how it works. Should be a solution. Any point in that orange area should be a solution. Okay, so we're going to try 3, 0 because it's inside that shaded area, the orange area. We plug it into the first equation, y is less than 2x minus 3. So y is 0, less than 2 times x, 2 times 3 minus 3. 0 is less than 6 minus 3. 0 is less than 3, which is true. You have to check it in both equations, so we'll go to y is greater than or equal to negative x minus 1. Substitute in 0 for y is greater than or equal to negative 1. Negative x is negative 1 times x. X is 3, so negative 1 times 3 minus 1. 0 is greater than or equal to negative 3 plus negative 1. I changed minus 1 to plus a negative 1 using the additive inverse. Negative 3 and negative 1 is negative 4. 0 is greater than or equal to negative 4, which is also true. Since both of these are true, we have in fact shaded correctly. The orange shading is correct, and any points that lie in that shaded orange area or on the blue line will be solutions of this system of linear inequalities. Okay, in the equation y is less than or equal to negative x plus 5, it had an m of negative 1 and a b of 5. So you would have plotted your y-intercept at 5, and that's the red line. And then you would have had a negatively sloping solid line, so it would have gone down 1 to the right, down 1 to the right, up 1 to the left. You only need a few points, I need many, so that I can draw a straight line on this graph. The next thing that you would have done is graph the other line. Y is greater than 3x plus 2. Your m is 3, your b is 2. So you plot a point at 2. You go up 3 and 1 to the right, 3 and 1 to the right, down 3, 1 to the left, down 3, 1 to the left. You connect that with a broken line because you have greater than, not greater than, or equal to. So no points that fall on the blue line will be solutions. Now, both lines are not passing through 0, 0, so they do not pass through 0, 0, so we can check with 0, 0. So for the first line, y is less than or equal to negative x plus 5 in red. You plug in 0, 0, 0 is y. It's less than or equal to negative x, negative 1 times x, negative 1 times 0 plus 5. 0 is less than or equal to 0 plus 5. 0 is less than or equal to 5, which is true, so we include it in the shading. Now here's how we include it. This may be where, this is the newest and the most challenging part. You put little x's on the side where 0, 0 is. So here's 0, 0. On the red line, you go to the same side as 0, 0 because you would want to shade to include it. Now we have to check the second line, which is the blue line. Y is greater than 3x plus 2. We substitute in 0, 0 because it does not pass through 0, 0. 0 for y is greater than 3 times 0 plus 2. 0 is greater than 0 plus 2, 0 is greater than 2. That is false, so we do not include 0, 0 in the shading. So here's your blue line, right here, here's your blue line. You don't want to shade on the same side as 0, 0, so you go to the left of that line and put little x's in blue all the way along the line. The place where they intersect, which is right here, you have blue lines, and then you go this way and you have red lines. Or you have blue x's, and then you go this way and you have red x's. That is where you shade to the left of those x's. All of the points that fall within that shaded area will be solutions. We're going to go ahead and plug in this negative 2, 1, which is in the shaded orange area, and make sure that this does come out and both of them are true. So the 1 is the y value, so it's 1 is less than or equal to negative 1 times negative 2 plus 5. This is the first equation. 1 is less than or equal to 2 plus 5. 1 is less than or equal to 7, which is true. Okay, the second equation is y is greater than 3x plus 2. We're going to substitute in the negative 2, 1. So 1 is the y value. It's greater than 3 times negative 2, the x value, plus 2. 1 is greater than negative 6 plus 2. 1 is greater than negative 4, which is true. So we know that from this check that we have indeed shaded this correctly, and that any ordered pair in that orange area and on the red line will be a solution of this system of linear inequalities. Okay, so we could check another point in this, and we'll go ahead and... Okay, so we're going to check a point that falls in the orange that's fairly simple, so let's go ahead and check 5, 1 will work. We'll check 5, 1, or 5, 0. Let's do 5, 0, it's easier. So we're going to plug it into both. So we're going to check 5, 0. We'll plug it into both equations. The x plus y is greater than 4, and we'll plug it into the 2x minus y is greater than or equal to 3. Okay, so you can see that when you check 5, 0, which is inside that shaded, that orange shaded area, those are all of the solutions that fall in that shaded area, which goes on into infinity. Plus solutions will be anything that falls on the blue line. However, nothing on the red line because it's a dashed line. This one's solid, so those are solutions. This one's dashed, so those are not solutions. So we substitute in to the first equation, x is 5 plus y is 0, 5 plus 0 is greater than 4, 5 is greater than 4, that's true. So far, so good. The second equation, 2x minus y is greater than or equal to 3. Substitute 5 for x. 2 times 5. Substitute 0 for y. 2 times 5 minus 0 is greater than or equal to 3. 10 minus 0 is greater than or equal to 3. 10 is greater than or equal to 3. That's true. So 5, 0 is in fact a solution, and we have in fact shaded correctly. We're going to go ahead and try another problem. You're going to try this on your own. It is also in standard form, so you're going to need to use x and y intercepts just like the previous example. 2x minus 2y is less than 6. 3x plus y is greater than negative 1. Go ahead and try this on your own, get as much done as possible, and whenever you get stuck or you're finding that you just want to check your answer, go ahead and turn the video back on because I'm going to go ahead and record the solution. Okay, for 2x minus 2y is less than 6, and for the equation 3x plus y is greater than negative 1, for this system of inequalities, you need to understand that this is standard form. And when it's standard form, to graph the lines, you should use x and y intercepts. So for 2x minus 2y is less than 6, the x-intercept would be an x value, and then the value would be 0. So for the x-intercept, 2x minus 2 times 0 is less than 6. 2x minus 0 is less than 6. 2x is less than 6. Divide both sides by 2, and you end up with x is less than 3. Now don't worry so much about that. This is just telling you its x-intercept, which is 3, 0. For the y-intercept, it would be on the y-axis. So the x-coordinate would be 0, and the y-coordinate would be a value. So 2 times 0 for the x minus 2y is less than 6. 0 minus 2y is less than 6. Negative 2y is less than 6. Divide both sides by negative 2. Reverses the inequality symbol, and you have y greater than negative 3. Now that's not really that important, the inequality symbol, but you should always practice it correctly. That's your intercept value, 0, negative 3, so you plot a point at 0, negative 3. So there's a point at 3, 0, there's a point at 0, negative 3. Draw a broken or dashed line because there is no equal sign on that first equation. Do the same process for the second equation. 3x plus y is greater than negative 1. It's standard form. X-intercept, which is going to lie on the x-axis. It's going to be 3x plus y value is 0. It's greater than negative 1. 3x is greater than negative 1. Divide both sides by 3. X is greater than negative 1/3. So the point on the line is negative 1/3, 0. That's right here. The y-intercept, the x will be 0, so 3 times 0 plus y is greater than negative 1. 3 times 0 is 0. Plus y is greater than negative 1. Y is greater than negative 1. So your y-intercept is 0, negative 1, which you can see right here. Draw your dashed or broken line because there's no equal to sign on this. So none of the ordered pairs that lie on the lines are solutions because the lines are dashed or broken. Now your next step, and this is where it gets relatively new, because in a system of linear inequalities, you have many ordered pairs that will be solutions. And you are going to have to determine which of those ordered pairs will fall into the solution category. You can see that neither of these lines, red or blue, are on 0, 0, so you can use 0, 0. The reason we use 0, 0 is for simplicity. It's easy. So we're going to check 0, 0 into 2x minus 2y is less than 6, and then we're going to check it 0, 0 into 3x plus y is greater than negative 1. First equation, 2x, 2 times 0, minus 2y, minus 2 times 0 is less than 6. 0 minus 0 is 0, is less than 6. That's true, and so we can include 0, 0 in the shading. So here's 0, 0. Here's your red line. You are going to put x's on the left side of that red line and include that side that 0, 0 is on. Now for the blue line, checking 0, 0. So 3x plus y is greater than negative 1. 3 times 0 plus 0 is greater than negative 1. 3 times 0 is 0 plus 0 is nothing. So 0 is greater than negative 1. This is also true. So you are going to include 0, 0 in the shading. So here's your blue line. You shade to the right, which is the side that 0, 0 is on. And then here's where you got to really pay attention. You have to see where the two intersect. So it comes down red, 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 and then, oh, blue, 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 blue. So you see this little place. All of the solutions that fall in that area will be